It's Livy, Tran, and these are my teammates.
I'm Charam, Charam.
I'm Likhit.
And I'm Nagendra.
And our project is a smart conveyor system with cloud-based monitoring and KPI-based health detection. So our project has a conveyor-based material handling process modeled in factory I/O, controlled with
Cloud data.
hold on.
That's when we use the sensor data like the sensor count, and we placed various sensors around the conveyor, and we collect the KPIs like throughput, work in progress, and health alert codes, which we will be explaining later. And we use that data and train the model to identify the jams and all the stoppage detections on the conveyor, and sends out an health alert code via MQTT and the database through a different website using Streamlit dashboard. And now Likhit Nagendra could explain the factory IO setup.
So we went with a straightforward yet a real-based system. So our setup mainly consists of three zones, which is the in-feed zone, buffer zone, and the out-feed zone. And we are mainly using two sensors, which are placed at the input and the exit of the boxes. So using data from these two sensors, we'll be able to determine the KPIs such as the work in progress and also the throughput. And we are using these sensors to also identify if any jams are occurring. And our system also consists of a roller stop in the middle. So this roller stop, we have currently given a time frame of 3 seconds. This mainly is used so that it can create a spacing between each boxes. So like in a real world scenario where if you want the boxes, a few number of boxes to be stacked together in any form of batches, they'll be able to do that with this roller stop. But it also acts to prevent any jams. Whenever a jam is detected in our system, this roller stop completely stops any more boxes from moving through. So that is the main use of the roller stop as well. We've mapped all these values to CCW for our ladder logic as well, which Likhit can explain more about.
So initially we created global variables which we mapped to factory.io, and then we used our first logic, which is for the sensor buffer, which is placed in the middle of the conveyor. We created a 3-second buffer so that there won't be any jams when the packages are being passed through the conveyor. Second, we use CTU counter to establish the count at the exit of the conveyor belt. This sensor will calculate the number of packages exiting. Then we created a loop logic for previous count and sensor count, which gives us the throughput values. Initially, the previous count value would be 0, and every 10 seconds, this data would be refreshed and updated in the cloud system. And then we've created work in progress logic using CTU again. For this, we placed a sensor in the beginning of the counter, and then we used subtraction. Two values between entry and exit would create the work in progress. The maximum capacity for our conveyor belt is 7. So we use two logics, greater than and less than. If the logic is greater than 7 boxes on the conveyor belt, it would create a data alert, heart alert code 1. And again, when the boxes are reduced to less than 7 on the conveyor belt, it would change back to 0.
We would like to start the demo.
Okay.
So these are the mark. These are the Modbus mapping addresses. So we use these addresses and we use Python to map both of them and then send them to MQTT, these values. And that starts. This gives through Modbus mapping. This gives sensor count, throughput, WIP, and also the health code. And this through through registers and Modbus mapping, this sends the value to MQTT, which you can see over here. All the values will be present: sensor count, throughput, health code, WIP, and this code is used to send the values from MQTT to Postgres and into our database, which can be seen here. The data will be going into data grip. We use that. Mm. And this is the random forest classification of the model which we trained. We took all the data for different datas like jam, overflow, and also normal conditions from data grip and trained this model. We used a rule-based classification, not an existing machine learning model. And with the WIP, throughput, and health alert curve data, we trained this, and it gives the prediction. Currently, the prediction is normal. And so this is the dashboard where we can monitor all of these values for the sensor count, the throughput and work in progress, and also the health code. And
The data on this refreshes
every 5 seconds, and we can change that to adjust that to 10 seconds and 5 seconds. So this is the predicted AI predicted the model we trained, and this is the actual model. Both of them are showing normal currently, and every 5 seconds it automatically refreshes. And we can simulate a jam. Uh, we can simulate a jam. So when there is a jam, inlet. This shows alert, and also the predicted value will also becomes alert.
This was the limit we've kept as 7, so it exceeded 7. That's okay.
This gives the alert code, and once everything is so I've stopped the I restarted the value directly, so without updating, so the values won't change since we stopped the conveyor and started again. But practically speaking, this becomes normal again once we refresh the code. And it becomes normal again, and the sensor count starts again.